Okay, my name is Mònica Campàs. I'm a researcher at IRTA. I'm going to talk about the rapid screening methods that we have been developing and optimizing and validating for several contaminants in seafood. Next. Okay, so we have been working on 3 different systems, one for regulated marine toxins. Next, please. Another one for the non-regulated marine toxins, and another one for the chemical contaminants, both regulated and non-regulated. So for the regulated, we have the amnesic toxins, Biorex toxins and paralytic toxins. For the non-regulated, the Tetrodotoxins. And for the chemical contaminants, the regulated, the polycyclic aromatic hydrocarbons, and the non-regulated, the perfluorinated compounds and flame retardants. Next. We have been working for the regulated marine toxins. We have been developing an optical biochip. It has been performed by Queen's University of Belfast. For the tetrodotoxins, we have been working on a magnetic bead immunoassay at IRTA in collaboration with the Queen's University of Belfast, who provides the antibodies. And for the chemical contaminants, we have developed an enzyme inhibition assay. This has been performed by ACTI, and in the 3 cases, we have count on the help of the company Biorex Food Diagnostics. Next. So we have been working on several seafood matrices for the regulated marine toxins, oysters, mussels, and also scallops and cockles. For the tetrodotoxins, oysters, mussels, and razor clams. And for the chemical contaminants, sea bass and salmon. Next, please. So let's start with the regulated marine toxins. We have focused on diarrheic surface poisoning toxins, in this case, the ocadic acid, dinophysis toxins, and also aspiracids. Also for the PSP, the saxitoxin, and for the amnesic ones, for the domoic acid. For all of them, we have been producing antibodies, and they have been really very sensitive in the picogram or nanogram milliliter limit. And in some cases, we have had to develop more than one antibody to be able to detect all the toxin congeners of the same family. Next, please. So, next, please, and next. For the optical biochip, we have been using a strategy that is based, as I said, on antibodies, and in this case, on microarrays. Here you can see the device. We have been optimizing 2 different steps: the extraction of the toxins from the shellfish, and then the detection using this optical biochip. Next, please. Here you can see an example, in this case for the saxitoxin, where you have your sample that you have extracted, you put it in your cartridge, and then until the incubation period, you can read the fluorescence using this reader. And here you can see the example of saxitoxin. As I said, if the saxitoxin is a sample has no saxitoxin, you will see these 4 brilliant dots. But on the contrary, if saxitoxin is present into the sample, this signal decreases. And this is a very easy way to detect toxin into a sample. Next, please. The idea, as you know, there are, as I said at the beginning, 3 different groups of marine toxins, regulated marine toxins, and the idea is to have a cartridge, a chip that is able to detect all of them at the same time. This is quite complicated because the toxins have different behaviors. Some of them are more hydrophilic, some of them are more hydrophobic, but we are working on that right now, and at least to have, for example, 2 different chips, one for the more hydrophilic ones and another one for the more hydrophobic ones. This is an example of what you could obtain. So different dots for the different detection of the different marine toxins. Next, please. And next, please. And you can go on, next. Okay, well, next, and another one, and that's it. Well, tetrodotoxin is a very potent neurotoxin that was discovered in pufferfish more than 100 years ago, and there are different analogies, like with the PSP toxins, different congeners of the same molecule with different small differences. And although they have been involved in many food poisoning incidents, but usually related to the consumption of puffer fish. However, in the recent years, as you can see on the right, they have been appearing in shellfish from different European countries. There is no regulation, we said this at the beginning, but anyway, the European Food Safety Authority has talked about the guideline value that has been observed that doesn't produce any toxic effect on humans, and this value is 44 micrograms per kilo. So we have been trying to develop a screening method that is able to reach this low value. Next, please. I think that now it will appear France. Yeah, these are the different countries where the tetrodotoxin has appeared. In our case, we have been using antibodies produced by the University of Belfast, and we have been using magnetic beads as supports. Here you can see that we have also two steps, the extraction from the shellfish, that is quite easy, just a heating step and centrifugation, and the detection. And here you can see the different bottles and different pieces of a kit that we have developed in collaboration with the company Biorex. Next, please. So also in the company of Biorex, they have been producing the kit, a prototype with the different instructions of the two processes of this complete assay, the extraction and the detection. And globally, we can say that this is a very fast assay. Just in 70 minutes, you can have the responses. It has been validated with different species. The performance of the kit is very good, and the limits of detection are as low as 1 ppb or 3.3 ppb, depending on the shellfish. But you remember I said that I talk about the 44 micrograms per kilo, so these are quite well below the limit that the EFSA is recommending. Next, please. Regarding chemical contaminants, you know the chemical contaminants are released into the environment and they can accumulate in plants and animals, and then they can reach humans through consumption. So we have been focusing on the 3 different groups of contaminants, all of them produced by industrial or daily lab applications. Next, please. In this case, our strategy is also based on the inhibition of, in this case, is based on the inhibition of enzymes. And we also have, like in the other approaches, an extraction and the detection. The extraction here, it just needs centrifugation and a cleanup step. And then the assay is performed on microliter plates using the enzymes and just incubating the different solutions for several times and temperatures, and finally reading the fluorescence with a reader. Next, please. So the performance has been also excellent. You can screen your positive or negative samples according to a threshold. The assay is quite fast. You can perform in 90 minutes. You will have very good performance. As I said, only less than 5% false negatives and very, very good limits of detection. The method is easy to use, so it's also easy to be implemented in the labs and is quite cost effective. And in this case, but also in the previous cases, as I said, we are working on screening tools. So we always suggest the use of a confirmatory method like chromatography when a positive sample is obtained. And next one, last one, please. So summarizing, regarding all the methods that we have been developing, we're quite happy because they work really well. They are rapid, they are highly sensitive, they reach the limit that we wanted to achieve. They are cost effective. Using them, you can screen a high number of samples and then just take the positive ones to confirm with other methods. They have been validated with fish or shellfish samples, so this means that they have been already tested in real conditions, and we have seen that they are quite easy to implement and to use in your labs. And next one, I would like to thank for your attention. If you have any doubts, here you have all the people that have been working on the different methods. Thank you.